the content of today's webinar is I will start with this brief introduction about myself and my company, the Reuse company, and the tools, the Requirements Quality Suite that make all this possible. Then I will introduce the topic and the concept of requirements pattern, also known as a boilerplate or statement level template. And then I will show some ways of making use of these requirements patterns with the Requirements Quality Suite, starting with the way these patterns help during the writing of the requirements, but also how these patterns can also help for requirements quality checking and requirements quality verification, as well as how these patterns can also help for knowledge discovery, knowledge elicitation, and for requirements elicitation or requirements discovering from unstructured sources. So as you can see, this today's webinar is kind of following up of the previous one that was hosted 1 month ago. So for those of you who are attending this webinar or watching this webinar as a recorded webinar, please proceed through our website just to watch the previous one issued in December 2016, before you watch this one. But if you are here, no problem, because I do believe that there is no need to have followed the previous one. It is just a recommendation in case you watch the webinar recording. So, first introduction, you know myself, José Fuentes, Chief Operating Officer of the Reuse company. In our company, the Reuse company, we are pretty much focused on traceability, reuse, and quality for systems and software projects. And our main customers are coming from the safety critical industries, let's say aerospace and defense, automotive, energy, railway. These are our main customers. And these are, as I said, our three main topics for TRC, for Reuse company. And these three topics are traceability, retrieval and reuse, and quality. So this is the core background of all of our technology, including the three tools that we will check and review today, Requirements Quality Suite. Most of my speech today will be around Knowledge Manager, which is the tool we use to create and match the patterns that are the key topic of the webinar. Most of our webinars are mostly dealing with RQA and RAT. However, you will learn something about KEM, Knowledge Manager, today, as a tool to manage patterns and to manage the rest of what we call system knowledge base, which is, as probably you remember, is composed of different layers of information. So this slide is coming from our previous webinar, where we introduced all these 5 layers of information. We will concentrate, we will focus today on the patterns layer, especially for 2 main purposes. First one is how patterns can help requirements authors while they are actually writing requirements. And second, how some advanced correctness metrics take advantage of these patterns just to provide additional features or additional accuracy. So, just as an introduction for the topic of requirements pattern, let me just say that it is a kind of sequential set of restrictions or placeholders. To some extent, we might say that it is a kind of grammar for a specific language, and in this case, our language will be requirements writing. So we use these patterns, as I said, for requirement writing, but also to create new quality metrics based on these patterns. You know that with RQA, out of the box, you have a large number of well-known metrics. However, you can come up and create your own metrics, and some of them are based on the concept of pattern. We will also see how patterns allows you to improve the accuracy of other quality metrics, not based originally in patterns, and we will see how knowledge can be elucidated and requirements can be gathered from unstructured sources, also based on patterns. So these are the principal usages of the concept of pattern. And here below, you can see what can be understood as an example of pattern. This pattern is a very well-known one, starting with the clause when, and then a condition element, and then a component, shall, action, object, and time constraint. So this is a pretty well-known requirement template. And let me tell you that out of the box in Requirements Quality Analyzer, you will find a bunch of these similar patterns, right? So in terms of what are the main items that you can see in these patterns or the placeholders, we technically speaking, we call all these placeholders slots. So for us, a pattern is a sequence of slots. And for each of these slots, you might represent what kind of information, what kind of element you are expecting for all these elements, as I said. So there are different possibilities, so there are different types of content for each of those slots. So I will start with the term restriction. So a slot can be just represented with a fixed term in our control vocabulary. Remember that in the previous representation, in all these layers representing knowledge in our knowledge base, remember that each layer is based on the previous ones. So when it comes to dealing with the requirements pattern, it's supposed that the dictionary is already done. So when you see here the word will, this will is just an entry in our dictionary, in our control vocabulary. So that means that you can represent whatever keyword or whatever concept as one of the elements in the pattern. In this case, it is will, but it could be shall, it could be whatever other element in the dictionary. Well, the second type of element in our patterns are what we call term tags. These are the typical noun, verb, pronoun, adjective, and so on and so forth. So you can establish that you expect a noun or a verb in whichever element in your pattern. The third one is a little bit more business-oriented, while the previous one, term tag, was, let's say, linguistic-oriented, the classical noun, adjective, and so on. When it comes to semantic cluster, in these semantic clusters, we are representing somehow the business domain. So that means that we could be expecting system elements or components or stakeholders or similar clusters of elements in our dictionary. Remember that in the second layer of our knowledge base, what we do is we classify together all the entries in the control vocabulary, all the entries in the previous layer are classified according to semantic clusters. So what you are doing here in this example is you are just saying that at whatever moment in your pattern, you are expecting a specific semantic cluster. That means you will be expecting whatever word from or concept from the control vocabulary, provided that this concept belongs to this cluster, to this semantic cluster. Well, following option for these slots is a combination between a term tag and a semantic cluster. So to some extent, you can find some concepts that can play different roles, and in this possibility, term tag plus semantic cluster, what you are forcing is whatever concept with or included in the semantic cluster of signal, provided that it is a noun. So probably in this semantic cluster of signals, you have the name of your signals, but you might also have the verbs that are representing how signals are sent from one side to the other, or signals are catched. So just by saying noun plus signal in this block, what you are meaning is that you are expecting whatever concept in the semantic cluster signal, provided that it is a noun. Well, Patterns, following is patterns sometimes are represented as an iterative approach where you can build patterns by reusing other smaller patterns. So this is what we call sub-pattern, meaning that you can create a small pattern that you can reuse in other larger patterns. And this is represented in these red boxes with square brackets, right? So if we go back to the previous example, here you can see that we are expecting on the one hand when, this is just a keyword, which is normally represented with the first letter capital, and then the rest is regular. And then this angle bracket is for a semantic cluster, the same for condition, for components, sorry. Shall is just the word shall, and then action, and then object, and then time constraint. It should be, by the way, it should be in angle bracket, meaning that it is a sub-pattern which is iteratively described in another pattern. So this is the key idea of patterns, and this is how we represent patterns. Just a couple of advanced topics about patterns. These screenshots here, by the way, are Knowledge Manager. So if you are RQA or RAT users, you have not seen probably these screens. These are the screens, I said, to represent how a pattern is built and managed. And you can find that this is the representation for an AND condition. So in this slot, let's say each of those blocks is just representing a so-called slot. First one, this one is representing an AND condition. It must be an adverb, and it must be within the semantic cluster of ly adverbs. Followed by another pattern which is represented, another slot which is represented by an or. In this case, it could be either a verb or the concept a couple of, which is a concept in our dictionary as well. So this is the idea. You can add more and more patterns just by, more and more slots just by clicking on the plus signs here in the screen, or you can be moving these slots or swapping the order of these slots just by clicking on the arrows here, and you can be adding more or options just by clicking on the plus sign here. And this is the way we deal with patterns. However, you will learn very soon how you can create patterns very easily just by providing a sentence which is an example of this pattern. Then, as a kind of advanced configuration for each of the slots in the pattern, if you just click on this button to display the advanced configuration, you can do something like saying that one specific slot in your pattern is optional, or one element in your pattern is a wildcard, meaning whatever is matching here until the end of the sentence, let's say. You can include exceptions for your item. So you can say, as you can see here on the top, this slot is a verb. However, the excluded terms, the exceptions are, as you can see here, all the modal verbs and auxiliary verbs that we don't want us to act as main verbs in our requirements. So you can here include a number of excluded terms for these elements. And finally, what we call here normalization rules allows you, for instance, to say, okay, I want here whatever verb, provided that it comes in a past participle form, which is, by the way, what I'm doing here with this second entry in this list. So this is, briefly speaking, the way to customize and to configure each of the different slots in a pattern. So you will see how to deal with this in a minute with a live demo. So the idea now with the Knowledge Manager is that when you install Knowledge Manager out of the box, you have a number of different patterns that allows you to write a wide variety of different types of requirements. Remember that different types of requirements will be probably described with different patterns. So the idea is that one pattern doesn't fit all. You will have to end up with a different number of patterns. So some of them are already included out of the box when you install our tools. Other patterns can be included in what we call libraries, and very soon you will see our a library market in our website where we will be offering a number of libraries. Of course, you can manage and tailor all these patterns in Knowledge Manager, and also, which is one of the key topics in our approach for requirements authoring and requirements quality. The idea is that aside of the knowledge architect in charge of the description of these patterns, when requirements authors are indeed using the RAT to write requirements, the requirements authoring tool to write their own requirements, they can find out that one particular structure is not yet described or defined as a pattern in the tool. So these requirements authors, they can just suggest, as you can see here, the author in this screenshot from RAT is suggesting a new pattern and this suggestion will be addressed. This is the suggestion, and the suggestion will be addressed in this in Knowledge Manager through this menu entry pattern suggestions, right? For the knowledge architect just to decide whether or not this suggested pattern should be part of the system knowledge base, right? So this is the way to deal with and to manage all these patterns. So let's start with the requirements writing, which is the first way to make the most of requirements. So as I said, requirements patterns represents the structure that every correct requirement should meet. So different types of requirements means different patterns or templates. And of course, these patterns are customizable for each different domain or customer or for the content of your own documents. And of course, as I said, we will be offering libraries for set of patterns, such as patterns for safety, acquisition, ISO 26222, the ER's easy approach for requirement specification, and some other. So here, now in this screenshot, you can see requirements quality analyzer. Provided that you have come up with a number of patterns in Knowledge Manager or with the out-of-the-box patterns in Knowledge Manager, now it comes the quality assurance people to establish what are the patterns that should be used for a specific document. So here in RQA, this is the screen that probably you know to describe what are the rules to be followed and what are the metrics to be followed. And there is one specific metric which is named as with a number. This is probably coming from a previous version of the tool, because this numbering, this R47, for instance, is meaning for the number of the rule in the INCOSE guide. So nowadays the current version is not having any more 47 rules. So probably this is an old screenshot. However, in your current version of our tool, you will have a similar, probably with a different name, but a similar metric. So if you want to check that all your requirements are meeting with any of the approved patterns, first you have to identify this rule, you have to enable the rule, and here on the top of the screen, you can select out of the overall list of patterns available for you. You can select with this screen, when you click on the pattern group selection, you just find the list of patterns available, and if you just right click, you can add or remove new patterns and pattern groups from this representation. So once you have established these patterns in RQA, now it comes to RAT to help authors writing requirements. So here, this is a RAT screenshot. Here you can see that we have this green frame here. This green is meaning the requirement as is written in the requirement box. The capacity of the fuel tank shall be 88 gallons. Is meeting or matching with the pattern that I have selected here on the top. In this case, physical property. So this is the matching pattern, right? And of course, I now, as a requirements author, I can see what is the structure of the pattern. If I just move the mouse over the name of my pattern, of the pattern that I have selected, I can see the description of the pattern, and I can see here in colors, I can see the different slots. This is the formal representation of this pattern, right? So this is the first way to deal with patterns in a way of helping authors in RAT, the Requirements Authoring Tool, to use these patterns while they are writing the requirements, right? So now let me show you how easy it is to create a new requirement. I will have a video so that I can have it shorter in time. I have just shortened some writing periods just to have it quick. So I will try to explain what I'm doing here in this video. I start with an empty list of patterns. So I will add a new pattern now, right? As you can see, there is no need to type or to enter all the patterns slots one by one. You just provide an example, as I did, and the tool is capable of analyzing this example and come up with this structure. So if you are happy with the structure, you just provide a name and provide a weight for the pattern. So this is my name, system plus action. And then I just group my pattern in this system functionality, right? So I have one pattern. And now here, let me test that everything was okay. So I write down a different requirement, and then I can see that my pattern appears here. So it means that this pattern is also matching with the sentence that I wrote. So it seems to be a good pattern. But however, now let me edit the structure just to have a more reusable pattern and more accuracy pattern. So here, I don't want whatever verb to be part of my pattern. I just want some specific verbs that I have clustered together in a semantic cluster called action. So here you have this and condition, a verb plus an action. And for the first noun, I will change the pattern slot just to say that it is not whatever noun, but it is just a system, which is will be fitting in as my pattern slot. So I go back and test again. And you can find that now something is different. Now this sentence is not meeting or matching my pattern. And the reason is because car is not having yet the semantic cluster of system. So I open the terminology, the dictionary, I select the concept car, and I put car within the semantic cluster of system. Now, car is a system name, and if I try to index again, I find that now, again, the pattern is matching. So again, I feel that this pattern is good enough. So let's go on with that. We have a tool to duplicate patterns, and now I will try to come up with with a couple of reusable and smaller patterns. So now I want a pattern for the system part and another pattern for the action part. So I will be removing all these elements, and then I have the article, which is, by the way, an optional element. And this is my system block for my requirements. And I will do something similar for the action. So I edit the second copy of the first pattern. I remove the beginning of the pattern, and then I keep the modal verb plus the action. So I have these small blocks that both together somehow represent what was represented previously in my first pattern. So I change, since this is just a small sub-pattern, a small block, and normally we represent these small blocks with small weight in our system, right? So now that I have these two sub-blocks, I will remove this element. And I will try to come up with a new pattern for the whole sentence again. So again, I write down my requirement. And then what the system is doing is the system is recognizing that this sentence is matching with the sequence, first the system and then the action. So this is exactly what I wanted. So I give now a higher weight, and I again join this into the proper group, pattern group. And of course, all patterns need a name. Okay, so now I have three patterns. One is a full pattern, and the other two are reusable sub-patterns. And I want to come up with a similar pattern to this one, but now not anymore for system elements, but for stakeholders. So it's as easy as duplicating my pattern and changing the system slot by a stakeholder slot. You can see that it is very easy to proceed with these changes. And of course, now I can create an entire pattern for something like the pilot shall fly the aircraft. And when you click next, then the tool recognizes that this is 3 blocks. First, a stakeholder, second, an action, and then a system block again. So if I am happy with this, I just provide a higher value, a higher weight, and of course I provide the name of my pattern. Very good. So let's go on working with that. And first, let's try to test if what we have done so far is indeed working. So I try with this sentence. It's matching exactly the pattern that I wanted. And now let's go back and keep working with this. I save all my patterns. A new one. The aircraft shall start the flight control system. Okay, so now the tool says, okay, you have one pattern which is a system plus an action, which is already a pattern, and the other one is just the agent, right? So I name my pattern. So the 3 elements in the pattern are okay. I name the pattern. I place this into this group, and I am done. So I keep creating larger patterns for larger requirements now, just by providing examples and by reusing the patterns that I have already written. But now I'm dealing now with a regular requirement. However, it starts with a condition when the road is frozen. So the tool says that the ending is a regular requirement. So I put this out because I just want to come up with the condition, with the first part of the requirement. Of course, I said first, sorry. Some people believe that or support the idea of having the condition at the end, not at the beginning. But in this example, it will be at the beginning, right? So once you are happy with your pattern, and by the way, for the verb, since this is a kind of state, I just want to say that it must come in past participle. It's frozen. Then I have all the elements, time of verb, and so on and so forth. So I name now my condition. And again, since this is a small sub-pattern, normally the weight for this sub-pattern should be less than the weight for an entire pattern, right? So I save it. And now I can paste again the previous example, and the tool will say, okay, this is no longer a sequence of different slots, but just a condition plus a comma, which probably is optional, plus a regular requirement. So this is now my pattern. It is done automatically, as you can see. So it is very quick to come up with a number of patterns. And of course, a higher weight. So now I am trying with a different condition. So this condition is different. And of course, since it is different, the tool is not recognizing that the first part is a condition yet. But I will try to do the same. I just remove the ending, and I name this as condition 2. I made all the arrangements for this pattern that could be needed. So for instance, I would say that this is not whatever noun, but a domain term, and the same for the road. It's a domain term. And probably this article is optional. Probably I don't want to find a comma, so I delete the comma. And I'm done with this pattern. Name and a weight. right? So as you can see now, I have two different options to write down a condition. What I'm going to do is I will start now with an empty pattern, and I will just say that I want a pattern which is including either of these two conditions. So I add the first one, and in there I am adding an or condition. So I want a pattern having condition 1 or condition 2. The good point of dealing with conditions in this way is that if you eventually come up in the future with more conditions, there is no need to update all your larger patterns. You just provide more or entries in this condition pattern and you're done. So now what you have to do is you just replace whatever pattern what you have been using condition 1 or condition 2, you just replace by condition, which is the or of the previous ones. Now let's try if everything is going well. So I try when the aircraft detects missiles in the trajectory of the aircraft, so I'll activate the anti-missile system. I can see that there is no pattern matching, but probably in this case it is because one of the entries, one of the terms that I have used is not having the specific cluster of domain term. So I just look it is there, but not anti-missile system. So I say that anti-missile system is a noun in the semantic cluster of, in this case, assist. So if you do that and come back to index again, now you find that this is matching with your pattern. So it seems that the structure for the pattern is okay. This is the end of the video. I hope that with this video now you are more familiar with the way of creating new patterns. So all these patterns are in full patterns, let's say, to represent the full structure of a requirement. That means that they could be very easily used in RAT, Requirements Outlining Tool, to write new requirements. However, as I said, there are other ways to use patterns. So let me briefly show you some of these other ways to use patterns. First, in the correctness section of Requirements Quality Analyzer, we provide a number of out-of-the-box metrics. However, we also provide what we call the parameterized metrics, meaning that the metrics that require some sort of parameter to work. In this case, there are three different types. So one example of metric created based on a pattern is just a metric where I can say, okay, I want to filter out all the requirements in my document with the type safety. So I use the attribute type from the requirements management system, doors or PDC integrity, whatever. You have an attribute called type, which is string equal safety. So I want all the requirements labeled as safety in this attribute to match the pattern system safety requirement that I have just created in KN. So this is a very easy way to check that the structure for this safety requirement is exactly what you would want. So once you create this metric as a parameterized metric in Activate, you have to come up with the proper ranges for the metric, meaning that if you find that your pattern is not matching, is the first row here, so you can see that the quality level is low and you provide whatever message. And however, if you find this 1, it is meaning that the pattern is matching, or the requirement is matching with the pattern, so you should be happy at least for this requirement and this metric. So this is the first way to use patterns as metrics. Another advanced way, that, by the way, I found a real customer in the US, it is that they came to me and said, okay, now we are forced by internal policy to write requirements not in the previous way we did when the speed of the car is below 5 miles per hour, but in any way, which is when the speed of the car is below 5 miles per hour, then open parentheses, and then a number of kilometers per hour. So, of course, there is no out-of-the-box metric in the Performance Quality Analyzer to deal with that, but very easily you can create two patterns, one with a small representation, just the number and the speed unit, and the other one with the full structure, number, speed unit, parentheses, number, speed unit, parentheses again. And then you just put these two within the same pattern group, and you create, so this is the example of the second pattern. And then in RQA, you just create this parameterized metric, providing just as a parameter the pattern group name and the pattern that you don't want to find. That means that is the short one. So if you create the proper ranges here, just when you say, okay, if I don't find this small pattern, then I'm happy, but if I find one representation of this small pattern, it's because the larger one is not present in my requirement, so I am not happy with this structure. And then, of course, in RAT, you can find that if I write a requirement in the old way, let's say the car is 5 miles per hour, then you have the red frame, meaning something is wrong, and you have your metric. However, if you rewrite, now say 5 miles per hour, 8 kilometers per hour, then you have a green frame here, meaning the quality for this requirement is high. So this is just another example. More examples on how to use patterns to improve the way RQA works is by having some sort of metrics that are written by or using the context to avoid false positives. So let's say that the classical problematic rule of avoiding passive voice. For most of the people, passive voice is not welcome for requirements. However, I do believe that when passive voice is coming as the precondition of the requirement, then it is okay. However, if it comes as the main action, then it is not okay. So if you just create a pattern just to represent the verb, the modal verb, or the verb to be, plus a verb in past participle, this simple rule, this is from the linguistic point of view, this is the way of describing passive voice structure, then this is some sort of misleading rule, and will end up providing false positives. However, if you have a broader context, including the shall, this is exactly what, in my opinion, is a problem. Passive voice when it is coming with the shall. So you just change your pattern, providing as the context for the passive voice the shall, and then in this case you will find that the begin when the car is started it will not be recognized as passive voice. However, if you see the active signal shall be shown, this is really a passive voice. So this is what you can do with patterns, and how patterns can help you to contextualize other metrics and to have more accuracy in the detection of passive voice, or more accuracy in this other example in the detection of other strange words such as around that could be welcome in some blocks of the requirement when it is coming together with a verb, but probably not when they are coming as an adverb together with a measurement unit, such as here, shall be around 2 kilos. So you can use patterns as well to contextualize and to avoid false positives. More information about patterns. Patterns can be used to filter out some other metrics. Not every of the metrics that we create in RQA shall be applied to all the different types of requirements in your specification. So you can filter out which of the requirements should apply for a specific metric, should be checked with a specific metric, just providing a pattern. So only those requirements matching with these patterns will follow or will proceed to be analyzed with the specific metric that you are describing in RQA, right? More ways of using patterns is using patterns to extract information for completeness and consistency. So most of the times, completeness and consistency are based on semantic graphs or are based on properties. So just by describing patterns, such as the one you have on the screen, you will be capable of extracting information from a textual requirement. So if you come up with the requirement, the capacity of fuel tank shall be 50 gallons, then by means of a pattern, we will be capable of extracting the property capacity of fuel tank equals 50 gallons, and of course, then we will be capable of checking this against the system knowledge base just as another consistency metric, right? Another ways of using patterns is for retrieval, information retrieval. You know that some of our metrics are based on semantic information retrieval, such as overlapping requirements or missing links, or we are now also adding requirements retrieval features to our tool. And in this way, our tool is not working as a regular retrieval engine just based on keywords. Our tool is based on the relationships that are extracted from the requirements. So that means that with the help of the patterns and with the help of the next layer in our system knowledge base, which is formalization layer, we can easily come up with a sort of semantic graph describing what is the information in the requirement. And this semantic graph is indeed what we use for the semantic retrieval capability, right? So finally, very quick, is a couple of other options that you have to deal with patterns. In this case, it is just to identify elements for your control vocabulary just by analyzing a requirements document. So if you just create a small and stupid pattern, such as I want a pattern with a noun plus a modal verb, or a modal verb plus a verb, then very easily you will be capable of creating rules in RQA, metrics in RQA, based on these patterns, as you can see here. And then these metrics in RQA are not indeed to analyze the quality of your specification, but rather to extract information. So very easily, if you analyze your document, you can see that here are all the elements that are nouns plus shall. So that is probably all these will be very good candidates to be part of our control vocabulary. So it is as easy as having this information on the screen. This is RQA, and just export this into KEM or export this into your dictionary. Right? And finally, the last feature is using, in this case, RFT, Requirements Authoring Tool, to identify requirements out of an unstructured source. So the idea is that once that you come up with a number of different patterns to represent your requirements, then you can input a textual document, could be PDF, Word, or textual file, and the tool will be analyzing sentence one by one, just checking for those sentences that really match with one of the patterns that was given as an input. For these sentences matching with the pattern, the tool will be identifying this as a requirement and will be storing this in whatever format that you want, Excel, DOS, PTC Integrity, whatever. So this is Requirements Authoring Tool, and here on the top you have a menu entry, Extract Requirements. When you click on this Extract Requirements, then you have this screen on the top for you just to provide what is the file. In my case, it is just a Word document, and what are the patterns that you want to use just to identify requirements out of this unstructured document. And then you just click on Extract, and you will have all your patterns in Requirements Authoring Tool. Right? And that's all from my side. So now it is your turn, just to provide questions or doubts or comments or ideas on regarding all this interesting topic of how patterns can be used to provide advanced quality analysis and to help authors writing requirements. So please remember that you are mute, so you cannot ask aloud. So you just use the chatting box to provide your questions. Thank you. Rules for the word used. Does the tool offer autocomplete suggestions? I can imagine the tool complaining with the user, somebody who is not perfect with English, not knowing the correct tense form. Oh, this is a very good question. Indeed, the current version of the tool is not helping you to correct. I understand that probably you are meaning something like if you have to write, the user has to write something like past participle I don't fully understand what you mean. Does the tool forces me or lead me in a kind way to end up with this past participle? If so, I have to tell you that the tool today is not helping you to this extent. It is just saying when you keep writing, the tool will say, okay, this is not matching with the structure because of this, but it is not replacing or providing the form that should be used. It could be a very nice way to enhance this feature, but it is not in that way. It is not leading you, but just checking, let's say. Okay, we have another one. Is there research to define the ultimate list of requirements patterns for functional requirements, patterns for performance, patterns for interface, and so on? Yes, we are, or let's say when you said ultimate is a strange word, ultimate. We are working nowadays in, as I said, in libraries, different libraries of patterns, and with the help of some other INCOSA members, we are also trying to come up with a list of requirements patterns that could be or should be included in the following version of the INCOSA guide for writing requirements. So does it mean that this is ultimate and complete list of patterns? I do believe that it is not easy to come up with a complete and ultimate list of patterns, but of course we are actually working in this direction to have functional, performance, and some others. I can try to ask a question myself because I was asked this question in an event that I attended last week. The question was something like, can you approach, manage to deal with other pattern libraries? In this case, the question was about EARS, this approach for writing for requirement specification. And the answer is that, of course, EARS patterns can be very easily adapted in Knowledge Manager. As you said, just by providing examples of the different or examples of requirements matching with these patterns, we can very easily come up with a set of patterns and two patterns just to provide the same expressivity as you have with EARS or with other pattern libraries or pattern approaches. Oh, the question is, what is EARS? EARS is I do believe that it is in the way to become a standard, and this EARS approach is just a kind of a catalog of different types of let's say patterns. I don't fully remember if they use the concept pattern. I believe that they are using the name template for requirements. But this EARS describes different types of requirements and one template or pattern for each of these different types of requirements. So remember that Knowledge Manager and our approach is very flexible in the way to deal and to create new patterns. So it is very easy to adapt to this EARS approach. So we will send you an email with additional information, and I will add a link to this EARS approach. One more question. Who within a company is the typical user of RAT, the Requirements Authoring Tool? Very good question. If we come back to the first picture in my slides, when I was trying to show them, the tools that we offer within the Requirements Quality Suite. Typically, RAT, this one is the tool for the requirements authors, while RQA is the tool for the quality people, quality assurance on the one hand and quality control on the other hand. And finally, for Knowledge Manager, which is the tool that you use to create your patterns, the idea is that in some of our customers, they are having some sort of new role in the process, which is the knowledge architect. This is the role for people in charge of managing dictionaries, control vocabularies, glossaries, taxonomies, and finally partners. So it is becoming a new role of knowledge manager in our customers. Thank you. Bye for now.